Well, kia ora everyone. Tēnā koutou katoa. I'm Peter Townsend. I am the independent chair of Te Papa Hauora, and you're in the Manawa building, which is a proud centrepiece of Te Papa Hauora. This is the beginning of what we're doing, and I want to tell you a little bit about Te Papa Hauora as we go on, but this building is now fully functional and almost fully occupied. We've got another building going up next door, which will be completed in September. University of Otago have just committed to a $178 million investment next door, just past the Pegasus Arms. And we've got another building going up where the old Oxford Clinic was, right on the corner at the end of the precinct. So that's really going to make this place very, very special in terms of health and in terms of health tech and in terms of education and research. So be part of it. Look, warm welcome to you. It's great to see you all inside in our nice, warm, safe building. And it's really my pleasure to welcome you and as part of Te Papa Hauora, your host for this joint networking evening between the Canterbury Health Innovation Network and Canterbury Tech. It's a blended meeting. You should make the most of that blending and work together. There should be a couple of slides. Yep, first one coming up. Te Papa Hauora, it's up there. You can see what Te Papa Hauora does and who it is. It's a unique collection of stakeholders involved in health education, research and innovation. Our partners include the University of Canterbury, University of Otago, ARA and the Canterbury District Health Board, and we work very closely together with Ngāi Tūhariri. Te Papa Hauora is really all about coordinating and facilitating health, education and research and interfacing businesses that are involved with health with the other stakeholders in health. So we're very much a part of your mix, and you're going to see a lot more of us as we evolve into the future. The Canterbury Health Innovation, Te Papa Hauora has been working with Christchurch NZ to reignite the Canterbury Health Innovation Network. This is our third event, and I'm so pleased to see so many people here tonight this year. The aim of the network is to connect individuals and businesses within Canterbury's innovation ecosystem, and that's what it's all about. So welcome to Canterbury Tech, and Neil Hamilton is over here, is going to come up shortly and update you on Canterbury Tech's activity. So tonight's event is special. Some of you have had a tour of the simulation suite just upstairs. Fascinating piece of technology and quite unique to New Zealand, having that sort of facility right in the middle of our health precinct. In fact, our health precinct is quite unique in New Zealand, which is exciting for all of us. So that is a purpose-built simulation centre here at Manawa. Its similarity to the clinical environment enables testing and validation of innovative ideas and technology without any risk to patients, which is important. So shortly you're going to hear about some of the technology innovations that are making a difference for patients, developed and supported by those within our health system. And we hear a lot of stories about the Canterbury health system, but we do some pretty special things in this health system, and it's the system that makes it all happen, and you are all, in one way or another, part of the Canterbury health system. I always remind people that health is 10% of New Zealand's GDP. We're the biggest business in town. We employ 11.5% of all employees in New Zealand are employed in health. So the opportunities are enormous, and as we go through the changes in health that we're about to go through with the Health and Disability Systems Review, for me that's about making sure that we realise all the opportunities that will come out of that change. Change is going to be big, but it can be very, very positive for us if we get it right, and we're going to get it right. Just a few health and safety issues before I introduce Neil. The bathrooms are located through the double doors behind you, around there. If you haven't been there yet, that's where they are. In the event of a serious earthquake, please just drop, cover and hold. This building is built to very, very high standards, and you're very safe where you are. Don't move out until you're told to. In the event of a fire, the fire alarm will sound and an automatic voice will tell you to evacuate. Our closest exits are the doors through which you came, another door around the corner. There's an exit over in the corner here, plenty of exits, and wherever you go out, please gather over on this side on the riverbank outside here if we need to vacate. Emergency assembly point, as I said, is on the riverbank. Please note the evening is being recorded. You should all be aware of that, particularly in Q&A. Just be careful what you say. It is being recorded, and I'll be facilitating some Q&A with the help of Neil a little later on, and that recording will be made available following the event. So without any further ado, it's my great pleasure to hand over to Neil Hamilton. Please give Neil a warm welcome.
Thanks, Peter. Thank you to Te Papa Hauora and Canterbury Health Innovation for doing this event jointly with us tonight. I'm the General Manager of Canterbury Tech. My voice seems to be going, so apologies if I need to reach for the water bottle. So Canterbury Tech likes to run some of these joint events through the year with organisations that we might not contact too frequently. So we do this to sort of bring our core tech audience together with different groups and spark a bit of collaboration that might not otherwise happen. So thanks. There's a lot of familiar faces in the audience, but there's quite a lot of new ones too. So welcome to all of you. Thank you. We don't have our own premises, so we're always on someone else's premises when we run our events, and we're thankful for that. And yeah, we have a new cluster sponsor. So we have a small number of sponsors that support Canterbury Tech through the course of the year, and they give us a modest number of dollars in return. So we're thankful for that support. Our latest is University of Canterbury Business School. And there's always a bunch of new members join at this time of year. It's usually because if you join around now, you get a member rate to come to our annual conference. So I'm not going to go through all of them. I'm sure that some of you are in the audience. If your name's up here, stick your hand up. 1, 2, is that all? 3? Okay, that's a pretty small number. Note those hands and go and talk to these people afterwards, please. And student membership's free for Canterbury Tech. We do that to encourage people to get to know the tech sector and our local employers. So around this time of year, we see a big bubble of students joining. Welcome to you all. Inevitably, I'm going to give a short pitch for our Tech Summit, which is our large technology conference. I imagine it will be one of the larger conferences in New Zealand this year, COVID permitting. Actually, if we have to, because of COVID, we will postpone it, not cancel. So it will run at some point in time, but currently scheduled for Thursday, 2nd of September. Ticket sales going well. So do get in quick, as it is nearly sold out, and that's not trying to inject a bit of FOMO. It really is the case. I do expect that we will sell out this year at 550 people, building back up to our pre-COVID levels of 700 at the Air Force Museum. And here's a few of our speakers. I have to say this because I designed it, but it's a really interesting speaker program. So please come along and hear a couple of stories. In the middle here, Vaughan and Sean, leaders of 2 of our tech companies that have gone through major exits this year. Vaughan, a mere $500 million exit, and Sean Maloney, locally over $1 billion exit. And my friend Abhinav on your right, who's just returned from 7 or 8 years in Boulder in Colorado to Christchurch. So a great selection of speakers and lots of networking time through the day as well. Our conference goers always tell us that 55% of people come for the networking. So we've listened to you and we've made sure there's lots of networking time through the day. And beautiful sponsors, we love you all. Some of you are in the audience, I know, so we appreciate your support. Every conference organiser says this, but we couldn't do it without you. We really couldn't. A few other local upcoming events. I'm not going to go through them in any great detail. Actually, the first one, it doesn't say how you find out more. So that's with Custom D and AWS. A few others there. Please check them out. You'll find, I think, links on our website and in our monthly newsletter at the right time as well. and some things going on nationally. Southern SAS particularly gets a really good review. I imagine that will sell out as well. You can attend either in person in Auckland or online, so take a look. And the Epic podcast is something we've been doing sporadically for 18 months or so. Usually Andy and I, and sometimes Helen. There's Helen at the back there, where Andy's somewhere in the audience. Yeah, there he is. The latest episode is Blair and Bill with Focus Software, and there's one other in the can, and there's a few others to come too. What do I know? I just turn up and do some talking. Other people do most of the work, as usual. So take a look, search for the Epic podcast or Canterbury Tech on usual podcast channels. And that's me, hopefully not too boring for you. Those of you that don't know what Canterbury Tech is, and some of you won't, you can all use a browser, so go take a look. Thank you. I'm not going to bother doing a sales pitch. You know, we're good at what we do. What can I say? So now on to the reason that you are here, which amazingly enough is not to listen to me. Find the right side of my piece of paper. So we have 3 speakers tonight, and hopefully they're in the room. That's good, they're in the front row, very sensible, thank you. We've got Richard Dove from CDHB Medical Physics and Bioengineering, Michael Sheedy, CDHB Medical Physics and Bioengineering, and Anya Hornsey from Via, tomato, yeah, okay. So a brief introduction to Richard, who's up first. Richard will provide an overview of the Medical Physics and Bioengineering Department, showcasing some of the technology innovations that made a real difference for patients, and the prototyping processes and the regulatory frameworks involved. So, welcome, Richard.
Brand, thanks for that. I'm not going to talk too much about regulatory. Nobody's interested in that, but come and have a chat with me later if you need to, want to. So I manage the Medical Physics and Bioengineering Department, working within the hospital. It's a team of around 35 people from various physics and engineering backgrounds, and my aim is really to take a bit of a romp through what we do, and let's see if that inspires any connections with what you're interested in. So let's start with some depressing news. Around 30% of us are going to get a cancer diagnosis at some stage. And about 12% of us are going to land up using or receiving radiation as a method of treating that. Good news is it can be highly effective. So our medical physics team is closely involved in this. And in the gap between getting a cancer diagnosis and being on the pointy end of one of the treatment machines, there's a whole bunch of work done looking at what's happening, how we can best use radiation to treat that, and how we can instruct the machine in what to do. So there's a radiation oncologist involved up on the top left there who's demarcating where your tumour is. We've got radiation therapists who are dealing with you during treatment when you're on the pointy end of one of our linear accelerators. And in between we've got medical physicists who are making sure that all that equipment and software is doing what it claims to do. If we're treating, let's say, a cancer in the spine, which is what those pictures are, we're trying to deliver plenty of radiation in the red to the spine, whilst not delivering radiation to the spinal cord, which runs right through the middle of it, of course. So it's a very delicate balancing act, and that's a large part of the attention of the physics team in the hospital to get that right. Now that big treatment machine down on the bottom right looks nice and patient friendly. It's nice, warm, glowing sort of ivory plastic covers. A tech audience like this will go, yes, but what's behind the covers? What's behind the covers is a whole bunch of technology. These machines are worth $2 or $3 million a pop, and we've got 4 of them here in Christchurch Public Hospital and another 2 in private. So we're talking a round gantry there that's a couple of tonnes in weight. It's full of electronics. Off that swings the treatment arm. That's probably another tonne. It's got wave guides. It's got high energy photons and electrons flying down it, and it's got a great big heavy mass at the end with little wee fingers moving in and out to control where the radiation is going. All that needs to be lined up so that it can treat that spine without delivering radiation to the spinal cord. So very fine tolerances, and there's one of our happy trainees. We're trying to get this thing so that as it rotates around our patient, it's within millimetre or sub-millimetre accuracy. It's a delicate game. So when you land up, let's say 12% of us are going to land up looking up the business end of one of these machines. You've got a bunch of medical physicists looking after the machines, looking after the software, making sure it does what it says on the label. In the diagnostic world, we also do similar functions to all the imaging equipment that's scattered through the hospital and through private practice. So standard X-ray that I venture to suggest probably everybody's been on the receiving end of, nuclear medicine, SPECT scans, computed tomography up on the top there, MRI, and ultrasound. So all those imaging modalities have got medical physicists working behind the scenes to make sure they do what they claim to do. And the sort of things we're doing are scanning standard test objects and looking, is the answer what we expect? Is the geometry of the answer what we expect? So that when we put a patient in there, we can trust the results that we get. Now that's grand. It's essential for patient safety, it's essential for efficacy of treatment, but the other thing it does is it means we're familiar with imaging and we're familiar with the images that come out, and that lets us do some interesting things. There's a few people out there that, surprisingly, have some quite large holes in their skull, either through trauma, motor vehicle accidents, horse riding, there's a range of ways you can achieve one of these, or maybe through a medical event and a section of the skull has to be removed because it's cancerous. That happens. Surprisingly, it's not that disabling, but you're certainly in a fragile state when you've got a large hole like that. Using CT scanning, we can get good images of this, we can create 3D reconstructions, and once we've got that, we can move into the engineering world and we can produce a permanent repair to that. So we use that 3D imaging, some 3D printing, to print out what we're dealing with. We press a titanium plate specific to the shape of the defect. After some finishing, we land up with a plate, as shown at the bottom right there, that is a permanent repair, can be screwed in place and issue resolved. So we've been making these for many years through development of technology. It's a bunch easier now than it was 10, 15, 20 years ago, and we produce these really as a national service. Far, far more common are minor issues, and a very common one, unfortunately, after a Friday or Saturday night punch-up in town, are defects in the eye orbit socket. So if you get a punch in the face, it's relatively common that the very, very fine bones at the back of your eye orbit get broken just by the pressure getting pushed back. And this maybe 3 a week in Christchurch, that kind of order. It's a more common thing. There are plates, titanium plates available to repair this, but but it's a tricky operation because you can't see what you're doing. They're working around behind the back of the eyeball, so a surgeon can't actually see what they're doing. Using, again, the same process, CT scanning, 3D modelling, printing out on 3D printer, we can give the surgeon a pre-operative idea of what they're dealing with. The plates can be cut, bent to size so that they can walk into theatre knowing that the plate that they've got is going to fit perfectly first time. And by doing this, we've sped up the operation, we've reduced the need to re-operate because it didn't quite fit properly. Let's say 3 a week maybe in Christchurch. Taking the concept a step further, and less common, there are instances where a section of the mandible needs to be removed. So jaw, typically through something like a cancer, needs to have a section chopped out. Once you take a piece out, it's very tricky to keep the geometry correct. You've still got your 2 joints up here, you've taken a piece out and it all starts floating around in free space. If you get it wrong, there's ongoing complications. What we can do is, again, using the CT and some 3D printing, we can create cutting guides that fit in a specific way onto the jaw and give the surgeon a guide down which he cuts. The repair is done using the patient's own fibula from their lower leg. They take a section out, same cutting geometry on that, same angles, same distance, and we then land up with a repair piece of bone that fits perfectly and maintains the geometry of the jawline. It's not all patient-specific stuff like that, though. We also do a good line in specific surgical instruments. There's a huge range of surgical instruments out there you can buy, but surgeons are craftspeople, and they like what they like. And we have the ability to produce stainless steel retractors in a particular shape, size, form that works how this surgeon likes to work, or an orthopaedic hammer, or on the bottom there is a rib spreader for premature babies. It's actually maybe sort of 5 centimetres in scale, just to give you some concept. We couldn't find anything on the market that was that small. So we're able to produce these in-house. Now, it wouldn't be 2021 or let's say 2020 without talk about PPE, because everybody loves some PPE. And if you recall back April last year, the world was going to end. As a health system, we were expecting vast numbers of COVID patients. PPE is really the only way of, well, it's the last line of defence, and we needed to get PPE out to anywhere and everywhere within the hospital where we were expecting these patients. The best place for it, we felt, was basically at the door of the patient's room, where you pretty much have to trip over it to remind you that, yes, you need gloves, gown, mask, and so forth. So what started as a very small, specialised, in a few areas of providing these PPE stands, to bring all that material to the forefront, suddenly became a major operation, and I think we produced 50 or 60 of these with the help of local industry. Since then, I think we're up to about 100 now scattered around the hospital. As I say, we've engaged with local manufacturers to help us with this, and this puts those supplies right at the place that you don't want to forget to put something on. So you trip over this, you will remember. So low tech, but incredibly valuable. Looping back to the start, this happy chap, that device he's using to ensure his linear accelerator is lined up to millimetre accuracy, made in-house in the department on those micrometer bases. So he's assured those are lined up. So what's the common link? Our why is around patient benefit. If we can apply our engineering skills to produce patient benefit, then it's the right thing for us to do, which is perhaps different to many of you who necessarily have to look to see, is this a commercially viable product? Because we're an in-house group, that commercially viable necessity doesn't apply. So what we find is that we're often working within niche applications where there maybe isn't a commercially viable product, but it's still incredibly valuable to a small group of patients, or those patient-specific applications where we're dealing with this patient's scans and producing something that this patient will benefit from. We do move into more general products, and Michael, who's up next, is going to talk about one of those. And I'm not sure if I'm introducing Michael. I am introducing Michael. So Michael is my team lead in the bioengineering team, and the bioengineering team is 10 people or so. It's quite a small group, and he's going to take it from there.
Kia ora, thanks for that, Richard. Yeah, great talking to lots of different industry people, and yeah, I suppose I'm the team leader at Bioengineering there, the component that Richard spoke about around some of that engineering side of things. I'm also co-founder of Hartwell Simulation, along with anaesthetist here, Dan Hartwell, hence the name Hartwell Simulation. So what I'm going to delve into a bit today is around one of the products or innovation that's come out of our department and working together through collaboration with our clinical partners within the hospital. And hopefully I'll give you a bit of an understanding of what the problem is and then delve into how we solve that problem. So simulation, what is it? I'm sure a few of you have had a go at Flight, Microsoft Flight Simulator. You've jumped on the Xbox. It's sort of similar to that. So I've just picked up a couple of examples here. So at the top there is a digger driver simulator, which is based up in Auckland. To the right, top hand corner there, it's a fishing vessel simulator up in Nelson, which I didn't even know existed, which is fantastic to see. So simulating the bridge of a fishing vessel so that they can run their cruise through. And then something down the bottom, which is a NH90 helicopter recently purchased by the RNZEF, and an environment where they train pilots in lots of different situations, and even before they even got the aircraft, so they had the simulator up and running. In the centre there is what we're used to on a day-to-day basis. And hopefully for those of you that went upstairs and had a look at the simulation floor, it's a clinical space where we can practice simulation in the healthcare environment. Similar to the process around that simulation in those other environments, we're trying to create a really safe container where we can practice and that people feel safe and can make mistakes, and then we can learn from those mistakes to make the health system better. And also, yeah, I suppose provide some learnings from that for the wider system. So some of the stuff that we practice, similar to the airline industry, is around those emergency procedures. In particular, I've just noted a couple around asthma and cardiac events. So running through the process of making sure that our procedures and practices are in place so that when that event happens, we can deal with it in a well-trained manner and have a really good outcome. As part of that is teamwork and communication. So it's a big part of working together in teams. So we've got doctors, nurses, allied health and sci and tech people, and it's bringing those groups together in an environment as well where we can practice working together and making sure that we're making good decisions. A big part of it too, as you see the NH90 simulator, is around training on familiar equipment. And you'll see in the clinical space there is an anaesthetic machine, which is a crucial part of equipment for an anaesthetist, just the same as the cockpit is to a pilot. So it's getting that familiarity around what does that switch to, so that you can confidently make those decisions and actuate them in the situation that you need to. So I'll talk a little bit around the environment, because that's important. So in healthcare, we practice in a couple of different environments. So the first one is the simulated one. So some of you will recognise that as the theatre space on the second floor here in Manawa. This space is designed to replicate a surgical theatre and is pretty close to it, but yeah, again, it's just a simulated environment. So obviously at the end there, we don't have big mirrors. One way that you sort of see more probably in a police station around interrogation. We use it more for getting an insight and controlling the simulator within that environment. And also it's a little bit bigger than what we would expect. Versus on the right hand side there, which is actually a brand new operating theatre in the Waipapa Hospital over here on the Christchurch campus, which is obviously the ultimate in fidelity, which is the realism. It's got everything there, it's in the size that you want, the space, so it's got all of those limitations and benefits, as well as all of the equipment you'd use, the systems surrounding those, like emergency bells, the drugs that you would use within those systems, and the wider sort of who do you call in an emergency. A big part of it is, especially for anaesthetics, is around how they engage with the patient, and quite often, well, 9 times out of 10 the patient is asleep, so there is little engagement during the procedure, and all of that is through the actual patient monitor. And again, in the simulated environment, that is simulated, and so it doesn't look, sound exactly the same as what they would expect to look. And you know, as an example, that's an actual monitor that you would see on an anaesthetic machine today if you walked up into the theatre. So it's the contrast between the two, the simulated and the clinical, I suppose, is important for what I'm about to talk next. Again, we wouldn't expect you to train, so you know, if we go back to the aircraft industry, I suppose it's getting training on familiar equipment. You wouldn't expect a pilot to learn on an Airbus aircraft and then say, right now you can jump on the Boeing, take off and you'll be all good, because everything is in different places, as I find every day when I go to turn the indicator on in our car and the window wipers come on. So it's important to get that understanding so we don't make those little mistakes which then escalate. So if I talk a little bit more about anaesthetics and just hone into the piece of equipment, which is, you know, some of you would have seen this on Grey's Anatomy and all of those medical programs where they try and simulate the health environment. And these parameters are really important around the subtleties of what those changes are and what that means for the patient that they're caring for. So it's important to replicate those and make those changes in a manner that's representative of the patient and what's happening with them at that time. So I'll just cycle through what they are. So the heart rate at the top there, which I'm sure you're all familiar with, it beeps at the rate that your heart's actually beating at. And the waveform is important around the shape and also the number. So in this case, it's 60 beats per minute. The next reading down is around your oxygen saturation level. So again, the waveform is important. So it's telling you how much blood is being carried, oxygen is being carried around the blood supply, which again is a really important measure. And subtle changes in that number can be crucial in picking up if something's going wrong early on in the procedure. Non-invasive blood pressure, I'm sure all of you have had that at the doctors, and well, no, for me, they've talked about the figure, making sure that I get it in the 120/80, which is, you know, generally through a blood pressure cuff, which tells the anaesthetist, the nurses, how well the heart's functioning. Then you have some invasive blood pressures, which are more actually in artery, so they're actually measuring the more accurate. If you're really worried about a patient that's, say, losing blood, or you're worried that there's a condition going on there, they can actually measure those pressures directly. Then we move into end-tidal CO2. So this is a really crucial part for an anaesthetist, and the reason for that is that these patients are asleep and the anaesthetist and the anaesthetic machine is actually breathing for them. So it's understanding how well they're breathing and how well their lungs are working in their whole system. And I'll talk a little bit about this a little bit further on, but that is a key figure in understanding how your patient on the table is going. The final thing, and it's like your own TV at home, there's menu systems. How do you drive through and get the best out of your system? How do you change the scale of those waveforms? How do you change the alarms so they're not annoying you and coming on all of the time? So the menu system within your own anaesthetic machine becomes familiar, and you learn how to drive through and change different parameters to make sure it's working most optimal for you. So now we understand what an anaesthetist is working with and what they're looking at to try and understand the patient. And Dan recognised this early on, so he wanted to do some simulation within their own environment to play on all those factors around learning how people work within their system and what things we need to improve on, not only within our own teamwork and communication, but the wider systems, especially in moving into a new hospital. Dan started off using biomedical calibrators, so each of these devices need to be checked to make sure the number that you're reading actually is saying the number that is actually on the screen, so it's important to check that. So Dan started using many calibrators to replicate the ECG, the oxygen saturation, the blood pressure. The trouble with that is they're designed for calibrating, checking the heart rate, and then moving on to the saturations in a linear fashion, not changing things dynamically. So Dan ended up a little bit like a DJ. I don't know, Dr. Dan DJ, it's got a bit of a ring to it. Trying to adjust all of these parameters within a scenario to make it look realistic for the anaesthetists and the anaesthetic techs and the nurses working on the patient. The other downside to that was that he had to stand right by the anaesthetic machine to do that. So you have to understand what people were doing as an intervention to then force a change and change the parameters to make sure. So if they're giving oxygen, you'd put the oxygen saturations up so it's having a good view of what's actually happening within that scenario. So Dan came to us, the Medical Physics and Bioengineering department, and had a chat around innovation, how we could help him out and make his job a lot easier and performing simulations so that they could get through more people and learn in those environments. What we came up with is a solution using a single biomed calibrator. So we discovered this device which has lots of parameters built in for testing a device. So the biomeds would go to the department and could check multiple parameters all at once. It's pretty easy to set up, so it's designed so that you can click your ECGs onto the actual device. You can clip the finger probe on for measuring oxygen saturation, so you're not actually disconnecting any of those safety circuits around the device and breaking into the electronics. So essentially it's like an electronic patient simulator itself. We also then took on that you need to control it wirelessly, so we designed some software that we could talk wirelessly through the device and made a simple, easy user interface so that anybody could pick it up, and you can see it's a slider-based system, change the sliders of multiple parameters, push update and push that out to the patient over time and make those changes and then look up again, okay, what are they doing next? Where do we need to drive them? So it was a great collaboration which worked really well, understanding anaesthetics and how they work within their environment, and then building on that to create the solution to enable them to do simulation a lot easier, and so Dr. DJ Dan could retire from the DJing. The part that was missing is the end-tidal CO2 So there was no solution. So we recognised, as I said, that that was a really important part of what an anaesthetist needs to understand around that patient. So we engaged a couple of companies out in local sector here, so Motivated Design and Analysis, and also Brush Technology. And we worked closely with them to work up a solution which was the Respire CO2. So this was a standalone device that also worked wirelessly with the same software, using a bike canister that you see for inflating tyres to provide the CO2 part, but allowed the anaesthetist to control the end-tidal CO2 waveform accurately and in a manner that they could understand. So again, it's around that waveform shape and the numbers that are associated with it. So you can see there that they've got an end-tidal CO2 of 40, which is a sort of normal figure, which is the upper value, and a lower value of 1, so that's your inspired CO2, so how much they're retaining, and also the arrest rate, so 10 breaths per minute. So that would be a fairly typical standard healthy patient. So it was important replicating all those other parameters, but also adding that into the anaesthetic machine as well to build that picture. And so that works really well together, and we've got those two devices coupled together, working off the single tablet to provide a high fidelity simulation within your own environment using your own equipment. And I suppose just to finish off, I wanted to show a couple of examples of where we've used that. So it's a device that we've got in use in a couple of places in New Zealand and also in Australia in a beta testing environment to gather some more data around how people use it. And top right there we've got ED, which was the old ED, around testing out the system. So you can see we've got a mannequin on the ED bed there in the trauma bay, and up on the actual patient monitor we've got some real value. So we work quite closely with St John's. They bring the patient in, connect the patient up as they would do, get the handover to the doctor, so we get all of that part of the process, and they can kick straight into using their patient monitor because it's familiar. They understand how to set up the menu to automatically set blood pressure readings, and it just gets that buy-in to that environment rather than a simulated monitor. And the Hartwell simulation unit just tucks in around the back out of the way, and we can stand over the side and control it. We've also, bottom left again, back in the anaesthetic suite, which is where we sort of looked at that design to hit that design, I suppose, around the most complicated simulation fidelity area that you can get. So there's lots of different parameters, and we use it for testing, say over in Waipapa when we shifted there, around those systems and processes to make sure before we actually engage. So Dan did lots of testing in there that the emergency bells work, that the phone works in those situations. There's enough space, where is the layout? So important again around engaging the users with your own monitors to understand, is the lighting right, the environmental impacts, as well as building on those teamwork and communication parts within that simulation. The bottom right one, believe it or not, is also Dan Hartwell. So he's wearing a mask, so we can use Hartwell Simulator with real patients because mannequins don't really move around or simulate some of the things that they have to face in a clinical situation around managing a patient. So in this situation, Dan plays somebody with anaphylaxis, so having an allergic reaction, flailing around in bed. And so we can have the Hartwell simulator set up on a real patient monitor to engage the clinicians around, okay, this patient's really sick, we need to do something, what's happening? And so rather than doing an orientation session around learning how that monitor works, they can just jump straight in, treat the patient, understand what's happening because they're familiar with how to drive it. So those are just some examples, and hopefully those that went upstairs got to see it in a different patient monitor environment used on a ward every day. So we're really excited about Hartwell simulation. It's been really useful in our environment around learnings and understanding teamwork and communication issues and our environment better, and we look to see it moved out into the wider health community. I'll hand over to Joanna. Anya Hornsey. So Anya heads up our VIA Innovation department within CDHB, so it's around engaging with innovation and all of you guys, people out here in the health tech community. I'll hand over to Anya.
Kia ora koutou. Johanna was my predecessor and heavily involved in Hartwell simulation, so he fell into that. Okay, so via Innovations, we're a small team of employees at Canterbury District Health Board who foster innovation inside the health system here. We have an executive sponsor, is also the Chief Digital Officer here, and that's James Allison. I'm not sure if he made it here. And Helen Lunt, who is our Clinical Innovation Director and also a diabetes physician. And we have Saxon Connor, who is our e-health lead and also a surgeon, and myself on the business side, and we're well supported by our corporate, legal and finance teams here. So that's our small team, and what we do is we foster an innovation culture through promoting idea generation, such as holding innovation workshops and helping innovators to develop and test their ideas that can improve the health outcomes in our system, and I'll run through 2 examples of how we do that today, and also in our sharing of innovation stories is another key driver, and together with Te Papa Hauora we run events like the annual Teki Breki as part of Tech Week, where we tell innovation stories from around the health sector. I've taken all the words, all the words the other guys didn't use in their slides and put them into mine, but bear with me. So one of the ways that we work with industry is that we structure and manage collaborative pilots to validate innovative ideas that can make a real difference to the Canterbury health system and the broader New Zealand health system. And for us, project success can come in a number of ways. It's not just confirming a pathway for spread and scale beyond the CDHB or for exiting to commercially viable ventures. It's also exiting to approve business cases for adoption into internal use because the pilots gave good validation data that made that case. Also further research or clinical validation trials. So we made a step change that means that we can attract more research or more funding to take them further. But even as simple as reframing ideas that people bring forward and helping them look at different ways that they can look at the problem and then just assimilate that into existing systems. Our why, I don't think we need to talk much about the fact that demand is greater than supply, a real problem, and that requires us all always to be doing more with less, to do it more equitably and to do it more sustainably whilst retaining that engaged workforce. And so that's a key part of our why, but also the expectation from Ministry of Health, especially in the data and digital space, that anyone seeking to develop innovation in the health sector should ensure that their innovation approach includes a service provider such as a DHB as an active partner. And that public healthcare organisations, if they're funded by the public system, should use commercialisation experience of the New Zealand Health Innovation Hub if there's commercial opportunity. So we're very strongly aligned in with the New Zealand Health Innovation Hub. Our current focus, obviously a bit of a strategic plan refresh to align with the new Health New Zealand and Māori Health Authority structures that have been announced. The shift from 20 DHBs to 1 DHB that's happening in this current financial year. But it doesn't change one of our key goals, which is to streamline our processes from concept through to exit so that we can help achieve positive impacts for patients and staff faster, more equitably and more sustainably. And some of the ways we're looking to do that is through communicating our assessment criteria and our processes, and I'll quickly run through an example of that. To keep building our ecosystem connections and trusted collaborative relationships that we have so that we can validate and exit faster. And we also have the aspiration of bringing Māori and Pacifica innovation thinking into our systems and processes to make them better. A couple of quick examples. One's an external innovation approach, reprocessing consumables, so single-use devices that wouldn't otherwise be diverted to landfill, getting reused and saving bottom line dollars while they're at it. And the second one is just a little bit more around the process of the Hartwell simulator and how it's come from that concept here through to a spin-out company that's about to be announced. So Just to give you a quick overview, a typical process, this is structured to a reprocessing one, but we go through the standard sort of triage and stage gate processes: approach, screening, discovery, due diligence, do a pilot, and then an exit can come in a number of ways. For reprocessing, down the closing a pilot off if we couldn't get sufficient data to support the case, a case for a further pilot, or a case for turning it into a business as usual supply contract. Standard down the side, some base criteria, some circumstance-based criteria, and that's really about understanding your customer and where they are in their cycle. Key stakeholders, and you'll see that's a big section. There are a lot of key stakeholders for any innovation in health sector. Decision-making and timeframes. So I know we're a bit short of time, so I'm just going to race through, but just to give you a quick idea, you know, people come in, we take them through a process, we evaluate those things, and we have a general timeframe. We then move on to looking at if people want to register to work with us. We've had the discussion of what we do, we had the discussion of what you do. We've tried to find connections, tried to find ways that this fits into the criteria for taking innovation forward, and for finding clinical champions and other executive support to get behind it. A lot of it's always timing, of course, and so that's what we look to do. Nobody has to come through us, but if they do come through us, that's the process we run through. And then we obviously will go through the discovery and a more detailed due diligence process before we actually get into running a pilot. And then a pilot can run from anywhere to 3 to 12 months, looking to validate that innovation solution and then exit through to there. As you can see, a lot of stakeholders involved, a lot of processes, but other than that, pretty much typical processes for taking a project through from concept to an exit. So one example that's worked well is a pilot we just completed with MedSalve, a local company reprocessing single-use medical devices. So instead of it going from hospital use to being collected and taken to landfill, they divert that, sort it, reprocess it, inspect it, put it back into a standard, into a original use standard, and then it comes back into the health system. And why this project has worked so well is because it hits some of those key criteria, including the business case. You know, this one delivered a return on investment in less than 6 months. In fact, pretty much from day one, bottom line savings. That helps get things up a prioritisation list. Sustainability, obviously with environmental footprint drivers, COVID, the timing with the supply chain problems under COVID means that helps the sort of innovation get traction. There was standard regulations, so the checkboxes that could be ticked, and that the risk could be managed because there were auditable standards or systems that the process could be audited against. The company's ISO accredited, and it was supported by data and evidence. And the final key point, obviously a clinical champion pool, and that came through from the nursing sector on this one, and the Transalpine environmental sustainability as well. And similarly with Hartwell simulation, so Michael's been through the why, and really this is showing the kind of process that started back in 2013, making sure from a business sense that there was freedom to operate, to use the calibration device in a different way, getting some peer review validation through a journal publication that shows enough traction to bring through to getting some grant co-funding. As you see, you get a little bit further on, and then get some market validation, go out and get some more funding. And then as Michael talked to, the key point being the end-tidal CO2. These guys went away and solved that, and got a patent application filed for that. So getting some barriers to entry in place against competition to help take that forward. Finding the right distributor, getting some beta units into market. There's 10 units around Australasia, getting that customer feedback, so that it's now on a point where we spent the last year with New Zealand Health Innovation Hub looking at commercialisation pathways, and that's about to be bootstrapped into a startup company at the end of this month, which is pretty exciting. First sort of spin out, and approved by the Minister of Health, which is another key process in innovation commercialisation from the public health sector. So again, reasons why this went well from a timing and cost perspective is in the fact that simulation tools aren't classed as a medical device, so it's a faster cheaper process to get through that stage, and same, there's no clinical trials required because no access to patients, real patients needed. Both from a health system impact and workforce teamwork improvement, patient care improvement, and it does more for less, so very high fidelity results for a lower cost means it's a financial proposition and that it's scalable, and other devices, add-ons, modular things can be brought in to make it into a business. Low-risk hospital-like setting for the prototype trial, so trialling something in a safe setting in a top-class sim centre that's here is a real added advantage. Channels to market, obviously you've got to find the right collaboration partner at the right time, and that's happened with the Australasian distributor that the Hartwell guys have pulled together. IP barriers and our inventive cross-disciplinary team, obviously, and access to local tech expertise here who we're able to work in and get product into the market. And the final point is really that the funding fits existing stage gates for accessing prototype and market readiness funding. So we're always looking to where can we get more funding or co-funding to help take projects through. Not only do we need the funding to take them forward, but also it gives some confidence and validation that other people are reviewing and getting behind the potential for it. So just quickly to summarise, not only do we do validation contracts with industry, we run a lot of and support a lot of activities to foster a culture of innovation. We work with innovators to clarify the IP ownership and to understand their goals, and we work alongside to make sure we're working with them throughout the process. We negotiate the various agreements that are required to take projects from one stage to another, and we champion ventures across the key stakeholder groups through our executive lead, the Chief Digital Officer. We support small dollar requirements between stages to help keep things moving, and we help identify and secure new co-funding and innovation to help take projects forward. We're looking always for opportunities to support the dissemination of the opportunities, such as publications and events like this, and we work closely with New Zealand Health Innovation Hub to shape and structure those that have a commercialisation pathway opportunity. And we're really excited at the moment with all the energy that's in the health sector ecosystem, and really enjoying being part of that, and all the energy that's coming through, Christchurch NZ with the Te Papa Hauora. We work closely with the University of Canterbury with the Think Lab, and Ministry of Awesome's Te Auhaka Lab, and Canterbury Tech, and there's a lot of activity and a lot of energy going in here at the moment, so we're excited to be part of that. Thank you.
Oh, thanks, Anya, and thanks to the other speakers too. That was great. You all spoke far too long, but that's very, you're excused for that because of the interest in the content of your addresses. So we've got now time for questions. We're going to have some more socialisation and due to wrap that up about 7:30. So we'll keep the questions relatively brief so you can get another drink and enjoy each other's company. But Neil's got a microphone there, so if anyone's got a question, would they like to throw it up and just identify which speaker you would like to respond to your question?
Would you three like to join us?
Yeah, come up on the couch, guys. Girls.
There's another mic there. We'll see if that one's working.
Just because I was always slow to start, maybe I can start. Richard, you mentioned that you have an interface between the private sector and the public sector. How does that happen for an organisation that isn't designed to make money, and how do you contract into the private sector with whatever you do? And I also heard you talk about having national services. So are they commercial, or is that through the munificence of the Canterbury District Health Board?
None of that nonsense. We charge them.
So how does that work in practice?
So for us engaging with the private sector, where we're using skills that are in town, that's easy. If that's a more economic way of producing a solution, we're happy to take stuff out and pay the private sector to produce stuff for us, if that's the most efficient way of doing it. The national question, well, that's all going to change in the next 12 months anyways, but as we stand at the moment, DHBs can charge each other. So if we're producing head plates for Auckland DHB, we'll happily charge them for it. Of course, a good chunk of them are picked up by ACC anyway.
Okay, thanks for that. Questions? Come on, there's got to be a question out there. I know you're all dying for a drink, but there's some really interesting stuff being talked about here. Anya, you talked about all of the interfaces you have with various stakeholders. I'm sure there are people in this room that would like to take advantage of what you offer. How do they do that?
They just contact via Innovations, either through a website or look us up on LinkedIn. And we are always that first conversation, but like the lawyers, the first conversation's always free. But we're very keen to engage with the ecosystem and see what we can do to help make connections. It becomes apparent pretty early on if there's some way we can work together, and then if you do want to work with us after having that conversation, then we just get you to fill in a registration form that makes it nice and clear how you want to work with us.
Thanks. Right, we've got a question at the back.
Yeah, Anya, you talked about some idea capturing days, like so your innovation days or creative. So how do you go about capturing all the ideas that come up during the day as people are frustrated with what they're doing or have bright ideas?
Yeah, and that one I was referring to a speed dating competition that we held in May. So we got 15 innovators from inside the DHB system. It was open to all employees to apply, to come along and to connect with 15 key stakeholders inside the CDHB so that they could explore ideas that they had in their workplace. This one was around technology and automation that they thought could help make their jobs better. But that was really a connection, so 225 new connections. We had people there from IT department, from privacy law, from IP, clinical, Ministry of Health, all sorts of people that are important key stakeholders, but it was really an opportunity for people to share their ideas and see what's stuck. And yeah, then there's quite a lot of follow-up to capture that and try and communicate that out in case somebody else inside the health system can pick it up.
Thank you. And there's always a lot of activity going on around this place, so keep an eye on what's going on with Anya's work and with Te Papa Hauora and all our other stakeholders. A lot happening. Another question.
With Hartwell, for example, how much perseverance is there needed to get something like that done in the, I guess, the health system?
I think I can obviously speak from my personal experience, and here in Christchurch in Canterbury DHB, the medical physics and bioengineering department has been, and the clinical engineering department have been incredibly supportive from the start, just in terms of letting me wander down and borrow their machines for a while initially, and then the link up with Michael and the team. I think one of the things that's really special for CDHB is that the clinical engineering and the medical physics and bioengineering department is over in the clinical building. So, you know, during the day it's very easy for clinicians on a number of the projects to wander down. I quite enjoy wandering down there and seeing all these lathes and machines and things. But you can go down there and just go and have a quick 5-minute chat catch up in a way that I just couldn't do that if they were in a separate building on the other side of the campus. And, you know, we actually had one of our partners sort of come over, and they were amazed at the setup we've got here, and they thought it was such a fantastic setup to have the ability to do all those things within the clinical environment. And so that's really kind of paved the way here. And then I was actually away on fellowship, and Michael continued working in the background and linked in with via Innovations. And so I came back from my fellowship in Canada after having a Zoom meeting over there, and it was already starting. And for me, it's just been great to have the Via Innovations team leading it forward. So I'm sure in other DHBs it would actually be really hard to sort of persevere and get onto this project, and I'm sure it wouldn't have got to where it has. It's just a pretty special setup we've got within CDHB that's kind of helped that along.
Yes, part of our special Canterbury health system. Final question. No? All right. Oh, yeah, one over here. We've got a final one over here. Yeah.
Always the furthest.
Thank you. Are you guys unique, or does the same structure exist in every other DHB around New Zealand?
Maybe not unique, just special.
I think they're pretty unique and part of a unique system, so, which is, we should never underestimate that here in Canterbury. Okay, everyone, I'm going to hand over to Neil to close out. So thank you, Neil.
Thank you, Peter. And just to conclude, I think all we need to say in conclusion is thanks to Peter and everyone at Manawa for hosting us, to all of our speakers tonight. Thank you so much. And to all of you for turning up, as you keep doing. We must be doing something right. Thanks, everyone. Stick around, do a bit more networking, and then get wrapped up well before you go outside.